In this video you'll see a live demo of a hierarchical system, from a question in the web UI, through the Orchestrator and Retrieval flow, all the way to a grounded response with a clear proof trail. The focus is on showing how the full infrastructure actually works step by step. Hello everyone, welcome to my new demo video. My name is Zoran, and today I'm going to show you a hierarchical project. So let me start with the simplest question. What is RAG? Simply put, RAG, or Retrieval Augmented Generation, means that an AI model does not answer only from its general knowledge. Before it responds, it first receives the relevant information from external data sources, and then it generates the answer. So, what is hierarchical? Hierarchical takes that one step further. Instead of just finding a few text fragments and hoping for the best, it introduces a more structured and controlled process. Information is discovered, connected, narrowed down, and prepared before it ever reaches the model. In other words, less improvisation, more order. As a cloud solutions architect, I wanted this video to show more than just a final AI answer, because honestly, almost anyone can show that today. What interested me much more was showing what happens behind the answer. In other words, the complete hierarchical infrastructure that makes it possible. That is why I built a live architecture for this demo in Azure. It runs in real time and serves as the foundation for the whole solution. I'm using Azure here, but the architectural principle itself is not in Azure specific. The same approach could be implemented on AWS or Google Cloud as well. So the point is not that this only works on one cloud. The point is to clearly show the architectural principle behind how a system like this works. My goal in this demo is to help people clearly see the full path to the answer. How the data is prepared, how it is organized, how the system finds relevant information, how grounded context is formed, what is actually sent to the model, and what the final answer is based on. That is really the purpose of this demo. In this project, I am not focusing on multi-agent architecture. I covered that in a previous video. Here the focus is on hierarchical infrastructure. For this project, hierarchical means hierarchical, or coarse-to-fine retrieval. This is not flat retrieval over chunks. The system moves through multiple logical layers, from a business entity to related documents, to relevant document sections, and finally to the evidence that becomes part of the grounded context key package. The model does not receive raw source data directly. It only receives the final grounded context package. Now let's take a quick look at the Azure resources used in this implementation. Inside this resource group, I have the core cloud infrastructure for this hierarchical demo. I am using a container apps environment where the backend services run. Inside it, there are three main services. The first is the indexing service, which prepares the data for retrieval. The second is the retrieval service, which finds relevant documents and evidence for a given question. And the third is the orchestrator service, which connects the full flow and returns the final answer to the UI. I also have a static web app, which is the front end the user interacts with. Then I have Azure AI Hub and Azure AI Project, which represent the AI layer of the solution. Azure Database for PostgreSQL plays a central role here because it serves as the main data and retrieval store. Azure AI Search is also part of the architecture as a supporting search layer. The storage accounts are used for source files and supporting artifacts that enter the hierarchical flow. And one important clarification here. In this demo, I am not using a real production CRM system because I'm working with fictional companies and demo business scenarios. Instead, I use blob storage containing files whose content and structure reflect the kind of information I would normally receive from a real CRM system and related business sources. So, the content is prepared for the demo, but the way the architecture uses it is realistic. So behind this demo there is much more than one model and one web screen. There is a full cloud system where each component has a clear role. That is the infrastructure view. Now let me look at the same thing from the architecture point of view. At a high level, this system consists of several key components. The first is the web user interface, where the user asks a question in natural language. The second is the orchestrator, which acts as the control center of the system. It receives the request, calls the retrieval layer, builds the grounded context package, prepares the model request, and returns the final answer. The third is the retrieval layer. Retrieval does not happen inside the model. It comes from a retrieval store that was prepared earlier by the indexing pipeline. The fourth component is the dedicated data preparation and indexing pipeline. This is a separate service. Its job is to read the business sources, normalize them, organize them, split them into logical units, build hierarchy, and prepare them for retrieval. The fifth component is the model itself, which in this project comes from Microsoft Foundry. But again, the model is not the center of the story. I use it only after I already have prepared and controlled grounded context. And the sixth component is the data itself, including account plans, meeting notes, CRM-style records, proposal summaries, renewal summaries, support and escalation summaries, and customer feedback records. Once I finished building the code, I containerized the applications and services into Docker images and deployed them to Azure Container Apps. As the main retrieval store, I use Azure Database for PostgreSQL, flexible server, with the PG vector extension. That is where metadata, hierarchy, embeddings, and retrieval data are stored. In this demo, I use the system from the perspective of my company. Contoso, Manufacturing, and Fabricam represent business accounts in the CRM and related source. For Contoso, I analyze renewal risk and support escalation. For Fabricam, I analyze the next best step in the proposal process. To make the system easier to follow, I use 3 business scenarios in this demo. The first scenario is renewal risk assessment for Contoso Manufacturing. The second scenario is a support escalation for Contoso. The third scenario is the next best step for the Fabricam proposal. The point of these 3 scenarios is not just to show 3 different answers, but 3 different examples of how the same hyper-AG architecture can guide the model to a relevant business conclusion. Now let me explain how the flow works from the user's point of view. This is also where it is important to explain my hyper-RAG indexing pipeline. In this demo, the original business data comes from Azure Blob Storage. These files are structured in a way that reflects what I would normally get from CRM system and other business sources. My indexing pipeline, running as a dedicated container app service, does much more than simply turn that data into plain chunks. Its real value is in how it organizes the data. It normalizes it, breaks it into logical units, and builds hierarchy, relationships, and layered connections between business entities, documents, and evidence elements. And that is really the key idea behind hyper-RAG. The value is not only in the data itself, but in how that data is prepared and connected. Because of that structure, the system does not search blindly. It moves step by step, from business entity to related documents, and then to the specific evidence that matters for the question. The prepared result is written into PostgreSQL with PG vector, where metadata, hierarchy, embeddings, and retrieval data are stored for later use. That is why retrieval here does not originate in the model. It comes from a store prepared earlier by the pipeline. Azure AI Search is also present, but here it plays a supporting role. It does not replace my custom pipeline. It complements it where that is useful. Everything starts in the web interface. The user asks a business question in natural language. For example, what is the renewal risk for a specific account? Why was a support case escalated? Or, what is the next best step for a proposal? At that point, the web UI simply passes the question to the orchestrator. That is where the real processing flow begins. The orchestrator first determines which scenario matches the question. It then calls the retrieval layer. The retrieval layer does not return the final answer. Instead, it finds relevant documents and the relevant part of those documents using a hierarchical approach. First, it selects the broader relevant documents. Then, within those documents, it looks for more precise sections. And finally, it selects the final evidence that will enter the grounding stage. That is the essence of the coarse-to-fine approach. Once Retrieval returns the results, the orchestrator does not send everything it found to the model. Instead, it builds a grounded context package. This is a controlled package of information that includes the scenario, the account, the focus, the estimated risk or status, as well as the extracted facts and evidence excerpts. This package is very important because it reduces the risk of hallucination and allows the model to operate within a narrow, relevant business context. In other words, the model does not receive the original sources directly. It receives only the final grounded context package. After that, the orchestrator generates the exact model request. In that request, the model is clearly instructed to answer only on the basis of the grounded context package, to stay concise, business-oriented and clear, and not to invent facts that are not supported by the evidence layer. That request is an important part of the demo because it shows that the model is not being allowed to operate without control. It receives precise rules and a carefully prepared context. Finally, the model returns the final answer. In this demo, that final answer can be controlled by scenario. But it is very important that it remains consistent with the grounded context package and with the model request. Now I move to the UI where I demonstrate all three scenarios. This UI is not meant to be a production end user interface. I built this UI specifically for the demo, so in one place I can show the question, the retrieval trace, the grounded context, the model request, and finally the model response. Let's first ask one question to get response to discuss results. For example, what is the renewal risk for Contoso manufacturing and what signals are driving it? For Contoso renewal risk, the system pulls together signals related to customer sentiment, renewal readiness, support escalation impact, and executive alignment. Those become the basis for a grounded business conclusion about renewal risk. The first box is agent interaction. This is the simplest view of the process. It shows the user question and the final answer returned by the system. The next section is retrieval trace. This is one of the most important parts of the UI because it shows that the answer did not come out of nowhere. It shows how the system arrived at the relevant information. Here I can show the scenario, the retrieval path, and the evidence selection process. Depending on the scenario, the system starts from the business entity, then moves to related documents, then narrows down to the most relevant parts of those documents, and finally selects the evidence that supports the answer. The next section is grounded context package. This is the structured package that gets prepared for the model. Instead of sending raw files or a large set of unrelated content, the system sends a controlled business context. Here I can show things like the scenario, the account, the focus area, the extracted facts, and the selected evidence excerpts. This is a key part of the whole architecture. The model is not expected to invent context. The context is prepared first in a structured way and only then passed forward. After that, we have model request. This box shows the exact request that is sent to the model. And that is important because it removes the black box feeling from the process. Here I can show that the model is asked to answer only from the grounded context, to stay concise and business-oriented, and not to invent unsupported facts. For technical viewers, this makes the prompt design visible. For non-technical viewers, it shows that the model is working within a clearly controlled frame. And finally, we have model response. This is the final answer that comes back at the end of the flow. But after seeing the retrieval trace, the grounded context, and the exact model request, that answer now carries more weight. Now let's ask questions for two other scenarios. First, why was the Contoso support case escalated, and what action should happen next? For Contoso support escalation, the system focuses on the support case, the business impact, the escalation state, and the next operational action required. And next question, what is the next best step for the Fabricam proposal and what evidence supports it? For Fabricam proposal, next step, the system pulls together proposal status, technical validation, commercial scope, and approval dependency, then turns those into a grounded recommendation for the next business step. So even though the business questions are different, the system flow stays the same architecture, the same discipline, and the same visible proof trail support each scenario. What matters much more here is that I can clearly show how it got there. In serious business environments, that is often more important than how fluent the answer sounds. It matters where the information comes from, how grounded context was formed, what prompt was sent to the model, and whether the model is relying on controlled context rather than guessing. So that was HyperReg in action. If I had to reduce this entire demo to one simple message, I would say this. This is not an AI system that only looks smart. It is a system that is controlled, traceable, and professional enough to be evaluated from a real business and architectural perspective. Behind a single answer on the screen, there is a web interface, an orchestrator, a dedicated indexing pipeline, PostgreSQL with pgvector as the central retrieval store, a Foundry GPT model that receives only the final grounded context package, and a visible proof trail connecting source data, retrieval grounding, model request, and model response. So, this demo is not just a demonstration of one AI answer. It is a demonstration of a controlled hyper-RAG architecture. In one of the next videos, I will return to this same project and expand it with additional enterprise layers such as MCP, APIM, security, and regulatory compliance aspects. Thank you for watching this video, and I'll see you in the next one.